Hi, my name is Brianna Wimer, and today I have the privilege of presenting our work, Beyond Static Labels, Unpacking Nutrition Comprehension in the Digital Age. This work is supported by the Food Information Networks project at the University of Notre Dame. Now, each food item has a unique nutritional markup, and nutrition labels are responsible for decoding these details, guiding us towards healthier eating choices. The United States Nutrition Facts Label is a mandated feature on food product packaging designed as a population-based intervention. Its primary purpose is to inform consumers about the nutritional content of food products, aiding in dietary management, allergen avoidance, and the selection of foods that contribute to a balanced diet. Nutrition labels also play a crucial role in nutrition literacy, which focuses on the capability to comprehend and utilize nutritional information for making informed health decisions. They empower individuals to assess the nutritional value of a food product and make choices that align with their dietary goals and health needs. Although nutrition labels play a pivotal role in helping consumers, many people still struggle with understanding them, and the main challenges include decoding the quantitative information provided on labels, such as nutrient amounts, recommended daily intakes, percent daily values, and serving sizes, assessing nutrient levels to decide if a product meets their dietary needs or surpasses what is deemed healthy, and performing nutrition tasks that require mathematical calculations. For example, calculating the amount of a nutrient consumed if intake exceeds the recommended serving size, or determining how many servings fulfill dietary requirements. Our research is driven by a straightforward query: how can interactive labels improve nutritional understanding? With the increased usage of online grocery shopping since COVID, there's new opportunities in supporting informed dietary decisions in online environments. So our study aimed to explore how we could integrate interactive features such as details on demand, visuals, encodings, and dynamic computations to see if they can address the typical challenges that consumers face. So we posed 3 research questions. First, to what extent does an interactive nutrition label enhance a user's comprehension of nutrition information? How does an interactive label facilitate product comparisons and related calculations within the same category? And lastly, how do users perceive the utility of an interactive nutrition label? In exploring how interactivity may empower consumers to make better informed nutritional choices, we aim to address some of the common challenges consumers face with traditional labels by introducing 3 key features. First, we introduce a details on demand feature across the label, offering instant access to nutrient information, recommended daily values, and guidance on interpreting the quantitative information. Users can easily access this information by hovering over any underlined element on the label. Second, we implemented a legend with visual encodings, using distinct shapes and colors to show which nutrients to consume more or less of, focusing on those identified as nutrients of public health concern. In addition, we used color hues to indicate low, medium, or high nutrient levels. For our third feature, we introduced a calculator function to address the importance of numeracy in understanding nutrition labels. This feature allows users to adjust the amount per serving directly on the label, dynamically updating the related nutritional details such as calories, percent daily values, and nutrient quantities based on the new servings. For the experiment, we conducted a controlled A/B experiment to explore our research questions, randomly assigning participants between 2 groups. Group A used traditional static labels while Group B used our interactive labels. The study included a think-aloud approach with 3 types of nutrition tasks, followed by interviews for deeper insights. Our study engaged 24 participants from South Bend, Indiana, recruited via local community and campus groups with a minimal age requirement of 18 and no other strict criteria to ensure a broad representation. The majority of our participants were women and predominantly African American. In our study, we customized 3 tasks from nutrition literacy assessments to evaluate participants' understanding of nutrition. The first task required participants to classify each nutrient level in a food product as low, medium, high, or unsure. This task was to assess how Group B participants utilized the visual encodings for their evaluations. To evaluate our calculator feature, we designed a nutrition numeracy task that included 6 mathematical questions. The first set of 3 questions asked participants to calculate total nutrients or percent daily values based on provided serving information. The second set of 3 questions required participants to determine the number of servings needed to reach a specific nutrient amount. For example, how many servings are needed to get 10 milligrams of iron. For the last nutrition task, we assessed participants' ability to compare nutritional content between 2 similar products, such as 2 different bags of chips. The task included direct nutrient comparisons and calculation-based scenarios, like determining which product had less sodium. Our first research question explored how interactive labels might improve understanding of nutritional information. In the Understanding Nutrient Amounts task, participants with interactive labels significantly outperformed those with static labels, achieving an 87.9% accuracy rate in identifying nutrient levels as high or low, compared to Group A's accuracy rate of 71.9%. Similarly, in the nutrition numeracy task, interactive label users significantly outperform static label users in nutritional calculations, with Group B achieving a 91.5% accuracy rate compared to Group A's 66.9% accuracy. Our second research question focused on the ability of interactive labels to aid in product comparisons. Our results showed non-significant differences between the groups, with a slight improvement in accuracy rate for the interactive label group. Our last research question delved into user perceptions of nutrition labels. Our analysis revealed several key themes, including the advantages of interactive labels, a strong desire for personalized nutrition labels, and insights on using interactive labels in daily scenarios. For an in-depth exploration of additional themes, including the limitations of static labels, individual assessments of interactive features, and the learning curve associated with these features, we invite readers to refer to the rest of our paper. Our first theme underscores the benefits of interactive labels. Through the nutrition task, we observed that participants in the interactive label group outperformed their counterparts. When asked about their decision-making process, many credited the features of the interactive labels for their improved interpretation of nutrition information. In addition, participants noted that interactive labels greatly facilitated their decision-making when choosing food products. For instance, participant 8 remarked, "I literally just used a legend, and Chips B had less percentage for the orange ones and higher percentages for the green ones," highlighting their dependence on the color-coded legend to determine the healthier option during a product comparison task. This observation illustrates how visual encodings can expedite evaluations of food products for consumers. Another notable theme we discovered was the desire for personalization in interactive labels, emphasizing the importance of labels being relevant to an individual's health needs. Participant 18's feedback brought attention to discrepancies between their interpretation of nutrient levels and the FDA's guidelines, highlighting the necessity for labels to also be adaptable to meet individual dietary goals, as not everyone adheres strictly to FDA guidelines. Similarly, participants advocated for labels tailored to unique body types and dietary goals, going beyond generic information to provide users with more personalized insights. One participant expressed a desire for nutrition labels to specify how a food product might affect their body type in particular, and to recommend products based on their individual dietary goals. In our examination of the real-world application of these interactive labels, participants expressed the belief that interactive labels would have a greater impact on purchasing decisions compared to static labels. This highlights the importance of improved nutritional awareness in shaping consumer behavior, and underscores how interactive labels can facilitate more informed food choices. However, participants also expressed concerns about integrating interactive labels into their shopping routines due to a preference for simplicity and efficiency. One participant noted, "I'm going to the store and it's got to be quick. I'm not necessarily going to be like, let me check this interactive experience first." This highlights the importance of ensuring that interactive labels complement consumers' existing shopping habits to be effective. Drawing from our findings, we've outlined design considerations and how researchers can leverage personalization in interactive nutrition labels. One crucial design consideration is incorporating flexible computation features to address numeracy challenges. Given that numeracy is essential for nutrition tasks involving calculations, it's vital to design tools that can accommodate diverse numeracy abilities, ensuring all users can gain insights from nutrition labels regardless of their numeracy skills. While our servings calculator could only adjust the amount per serving on the label, additional functionalities that enable custom calculations for quantities or percent daily values could allow users to specify their nutritional goals, and in response, the system could provide their serving sizes needed to meet those requirements. Enhanced focus on mechanisms for product comparisons underscores the importance of improving the ability of users to compare different food products effectively. Contrary to our expectations, our findings showed that participants using interactive labels did not demonstrate a significant advantage in comparative tasks compared to those using static labels. This indicates an effective interactive label may improve comprehension of individual products, but that may not necessarily result in improved efficiency when comparing products. On the other hand, visual encodings, especially color, was very helpful for participants using interactive labels for the product comparison task. They heavily depended on color cues to compare the products, specifically to identify which product had more favorable or less favorable nutrient amounts. This emphasizes the significance of visual encodings in assisting users to make informed dietary decisions. Following this, intuitive visual encodings for nutrition interpretation is pivotal for enhancing user engagement and understanding. Visual encodings play a critical role not only in product comparison but also in overall nutrition interpretation, aligning with the purpose of front-of-package labels. These encodings facilitate quick assessments, allowing consumers to swiftly grasp the nutritional content of products and make healthier choices. There is also an untapped potential in creating comprehensive visual representations of nutrition information. Such visualizations could simultaneously convey various aspects of a product's nutritional profile, enabling consumers to assess different nutrients, benefits, and drawbacks more effectively. Incorporating visualizations such as glyphs or matrices or other multidimensional representations has the potential to deepen consumers' comprehension of a product's complete nutritional profile. Additionally, incorporating visualizations of part-to-whole relationships from nutrition labels can be advantageous for users with diverse numeracy abilities. These visualizations can clarify concepts such as the percent daily values and serving size within a product, offering consumers a clear understanding of its nutritional composition. Embracing personalization within nutrition labels opens new avenues for user engagement and dietary management. By enabling user-driven customization, labels can become more relevant and useful to individual preferences. Feedback from our study highlighted a strong preference for labels that prioritize key nutrients. Users wanted the ability to rearrange nutrients, such as putting the vitamins to the top of the nutrition label. Additionally, there was also a clear interest in further customization, with users seeking labels that not only rearrange but also highlight specific nutrients. This dual functionality aids in managing dietary needs and achieving health goals by emphasizing nutrients of personal significance. Integrating information specific to different demographics into nutrition labels also offers a chance for tailored and more impactful dietary advice. Acknowledging the idea of adaptable daily values suggests that the one-size-fits-all approach of standard daily values that are based on a 2,000-calorie diet doesn't accurately meet everyone's needs. Factors like age, weight, gender, health conditions, and activity levels, including unique situations like pregnancy, mean that nutritional needs vary widely among individuals. Customizing nutrition labels to reflect these personal differences can greatly improve their usefulness and relevance, making dietary guidance more personalized and effective. For our concluding thoughts, we highlight how interactive features such as calculators and visual aids significantly enhance the understanding of nutritional information, moving beyond the constraints of traditional labels. We hope our research demonstrated the potential of digital tools to improve nutrition literacy. And as we reach the end of our presentation, I'd like to extend my heartfelt thanks to my co-authors and the rest of the Food Information Network's project team, whose invaluable contributions were instrumental to this paper. Thank you.